Alright, so we are back, and we are going to be doing problem 13 from the AMC 10B 2016. So, this seems like a really difficult problem, but really, this is very easy for problem 23. Personally, I think this was easier than the problem 19, but this one is pretty straightforward to find, so this one should not have been a 23. So in regular hexagon, A, B, C, D, E, F, points W, X, Y, and Z are chosen on these sides, and respectively, so A, B, Z, W, Y, X, and E, D are parallel and equally spaced. What is the ratio of the hexagon of the smaller one to the whole regular hexagon? So let's draw this out. Sorry about this, but I'm probably going to draw it really bad. So we have this. No. This is not a good picture. I'm not good at drawing hexagons, but what this will do, this will suffice. So we will go 1, 1, 1, 1, 1. Right. Now we have W on BC. So let's just call this A, B, C, D, E, F, and W on BC. So should look something a little bit like this. Have this. This is not an accurate diagram. Just don't keep that in mind. This is not accurate, but we're given that these are parallel. And we are given that this length is equal to this length is equal to this length. Oh yeah, and sorry, it did not the question did not include that it was that all the sides had 1 or AB was equal to 1. I just chose 1 because that will be the simplest number to choose for this side. So we are given this, and now we have to find the area of this inner hexagon minus the whole hexagon. So to find the area of the whole hexagon, we must know that a regular hexagon is composed of 6 congruent triangles, as shown. 6 congruent equilateral triangles. So sorry, these are not congruent and equilateral, but it's the best I could do. So I'm gonna have 1s, and these are all 1s. And so we know that because this is a 30, 60, 90. Know that this is, wait, no, this is not 1. This is 1, this is 1/2, and this height is √3/2. So the height, or the area of this triangle, is going to be 1/2 times √3/2 is equal to √3/4. And then you multiply that by 6, so equals √3, or 3√3/2 is the area of the hexagon. So we're going to find area of the inner hexagon, and it's going to go like that. So we've already solved, not really 1/2, because that's not the difficult part. Difficult part is finding the area of the hexagon, and it's honestly not so difficult to find that. So in order to do this, we must find the height of the hexagon. So we can kind of draw a height right over here. We know that this is perpendicular to the base, and can draw a diagonal, and that's going to help us a lot. So let's try and clean this up, and I'm going to write down the area so I will not forget it. Alright, I'm going to create something new. So this is another terrible hexagon, but so we know that it's composed of 6 congruent triangles, 6 congruent equilateral triangles, and we compose an altitude right over here. So because these are equilateral, and we know that we assigned the side length 1, this is going to be 2 times 1, because it's 2 of the side lengths of the equilateral times 2 because it's just this side length, which is 1, added to this side length, which is also 1. And we know that this one is going to be 1 because it's the side length of a hexagon. So now this kind of shows that this is going to be root 3 because this is a 30, 60, 90. This is 30, 60, 90, and this will be root 3. Or you could just use the Pythagorean theorem, so 1 plus h squared is equal to 4, so h is equal to square root of 3. So now that we have that, we have the height is equal to square root of 3, and it is given that this thing divides the whole hexagon into 3 parts, or these 3 lines divide this whole hexagon into 3 parts. So now we know the height of this inner hexagon, which is key, perfect. So the height of this inner hexagon is root 3 over 3 because it's just the whole height, which is square root of 3 divided by 3. So after we know this, now we have to find the area. So just by taking a look at this, you know that this is 2 trapezoids divided in half. It's symmetrical, so it's just the area of the trapezoid times 2, and we know how to find the area of a trapezoid. There isn't really a formula to find the area of a hexagon that is simple, I believe, but area of a trapezoid easy to find, so we can try and do that. So we're going to have 2 times the area of the trapezoid because the area of the hexagon is just 2 of them, 2 trapezoids combined, 2 times the area of the trapezoid. And we know that the area of a trapezoid is the average of the bases times the height. The average of the bases times the height. So we already know the height of one trapezoid, and the height is going to be equal to root 3 over 3 divided by 2 because that's the height of the whole hexagon, and the height of a trapezoid is just the height of the hexagon divided by 2. So it's going to be equal to square root of 3 over 6. So now we have average of the bases times square root of 3 divided by 6. So now we have the height, and we found one of the unknowns, and now we have to find next to the bases. So we know that this whole base is just 2 side lengths of equilateral triangles. You can really visualize it in this picture. So you can just visualize this equilateral triangle side length plus this, which is just 1 plus 1. So the base, let's name the larger base sub 2. So base sub 2 is just equal to 2 times 1, which is equal to 2. So now we have base sub 1 plus base sub, I'm gonna erase this out. So 1 plus 2, and we're just going to simplify this, times square root of 3 is equal to, the 2 times the area of the trapezoid is not equal to that. It's just the area of the hexagon. So the area of the trapezoid is equal to that. So don't get them confused. This is a pentagon, whatever. Sorry, I think I have major OCD. Wait, no. Area of the trapezoid. So now we're gonna have to clear this up. I'm gonna write this down so we have, because we're gonna need to have more space to do the rest. So we're gonna create a new one. So we know that base of 1 plus 2 square root of 3 over 12 is area of trapezoid. So now we can just draw this hexagon right again. So now the next question is, how do we find this base? Or how do we find this base? I don't really know how to highlight, but if I could highlight, that would be good. Oh no. Nope. Maybe if I do this, it might help. How do we find the area of these bases? Oh no. So I kind of highlighted it. And so what we're going to do is conduct similar triangles. So what we can do is splice this. Did I say splice? Well, I mean, you could go either way, slice or splice. And we know that this side length is 1 and this side length is 1. So we can just conduct similar triangles and find this base right over here. So let's do that right over here. So we have this similar triangle, and since this whole base is equal to 2, one of the bases right over here is going to be 2 minus 1 divided by 2. The reason being is because 2 minus 1 will get you these two added up, and then you divide that by 2 and you get just one of the bases, so it's equal to 1/2. So we have this larger base equal to 1/2, and then we have this upper height, and we know that the whole height, or I don't know, whole height is equal to √3, and because this is symmetrical, the whole height of this triangle is going to be square root of 3 divided by 2. So we have square root of 3 divided by 2 right over here. And now we already know the height of, or we already know the length of this triangle. The length is √3/3 because it's just including the part where it's divided by 3. This is still equal, or it's still trisected, so it's still going to be √3/3. So now we set up similar triangles. So we're going to have the larger triangle divided by √3/2 is equal to this smaller base. So base, let's call it base of s, bs, for the smaller base, and divide that by 1/2. Wait, yeah, divide that by 1/2. So now we can cancel out the 1/3, and we find that bs is equal to 1/3. So this is going to be equal to 1/3, and now we pretty much have done all the difficult parts. It's just adding everything together. So the base sub 1, as you remember if you wrote it down, base sub 1 is going to be equal to 1 plus 2 times base sub s, which is equal to 5/3. And then now we can plug this in. So we know that base of 1 is equal to 5/3. So now plug it back into our formula. Area of, whoa, that's terrible. Area of trapezoid is equal to base of 1 plus 2 square root 3/12, which is equal to 5/3 plus 2 square root 3/12, which is equal to 11√3, or no, not 11√3, 11/3 √3/12. And finally, area of the inner hexagon, let's call it inner hexagon, is equal to 2 times area trapezoid, shown before, which is equal to 11√3 over, this is going to be 11√3 over 18. So now we have that 11 root 3 over 18 is the area of the inner trapezoid. And as you remember, it's going to be, as the formula said before, it's going to be 11 root 3. That's the area of the inner hexagon divided by 3 root 3 over 2. And that's going to give you 11 root 3 over 18 times 2 over 3 root 3. These cancel out, and that also cancels out, so that means you get 22 over 18 times 3. Just equal to 11 over 9 times 3, and that gives you 11 over 27. And C will be your answer. And as you could see, tackling this problem was very easy for a problem 23, and it wasn't that complicated. So yeah.